தம்பி பேசுறது கேக்குதாப்பா?
Yes, sir.
ஓகே, தேங்க்யூ. Hey guys, today we are going to discuss about electronic fuel injection system and electronic fuel injection system in both petrol and diesel engines. So this is what we are going to discuss in today's class. In previous class also we have discussed a lot about the ignition system and engine management systems and what are the various types of sensors and actuators used in IC engines and all automotive vehicle systems. So this is what we discussed in the previous class. Okay, today's class, let us discuss about the basic electronic fuel injection system, okay, and ignition system in IC engines, both the petrol and diesel engines. Okay, this is a basic operation of an four-stroke IC engines. Because in four-stroke IC engines, you know very well there are four strokes. Four strokes. One is suction stroke or intake stroke, compression stroke, and power or expansion stroke, and exhaust stroke. Here, for your understanding purpose, so it is clearly mentioned intake stroke and ignition stroke. Okay, so this is for your understanding purpose. Uh, in petrol engine, so during the suction stroke, the inlet valve will be in opened condition and the exhaust valve will be in a closed conditions. So when a piston is going to travel from this top dead center to bottom dead center, the vacuum will be created inside of the cylinder and the air fuel mixer will be entered into the cylinder. Okay, so this is suction stroke or intake stroke. So during this time, the exhaust valve will be in closed condition. Okay, so this stroke is called as intake stroke because air fuel mixer is going to enter into the cylinder in petrol engine or spark ignition engine. Okay, so similarly in diesel engine, during the suction stroke or intake stroke, only the air is going to drawn from the atmosphere. Okay, the only air is drawn from the atmosphere and that air will be entered into the combustion chamber. Okay, that air will be entered into the combustion chamber. So the air is going to filtered with the help of air filter because the unwanted dust particles may be enter into the combustion chamber. So this is going to be avoided with help of the air filter. So we will come into the next step, compression stroke in petrol engine. So that during the compression stroke, both inlet valve and exhaust valve both will be in a closed condition. The piston is going to travel from this bottom dead center to top dead center. So when it moves from bottom dead center to top dead center, the air fuel mixer ratio will be compressed at very high range. Okay, and here air fuel mixer both will be compressed in petrol engine. You just look into this diesel engine. In diesel engine, only the air is going to be compressed at very high temperature. Okay, the high pressurized air is going to be compressed at very high pressure. Due to that, air is going to be heated at very high range. And we will come to the next point, ignition stroke. Okay, this is power or expansion stroke. At end of the compression stroke, so in SI engine, spark ignition engine or petrol engine, so we are having spark plug. That spark plug is going to be ignited. The spark plug duty is it will ignite spark. So at end of the compression, the spark plug is going to ignite the spark. So the air fuel mixer, highly compressed air fuel mixer is going to be burned inside of the combustion chamber because here the chemical energy is going to be converted into heat or thermal energy. Then heat or thermal energy is going to be converted into kinetic energy. So the explosion is going to be happening inside of this combustion chamber and piston. The piston is going to be pulled down. So the piston will come from top dead center to bottom dead center. So the similarly in diesel engines, so the air is heated up very high pressure, nearly 35 bar. At end of the compression stroke in diesel engine, so the fuel diesel is going to be sprayed into a fine particles or droplets. So immediately, the due to the high temperature of the air present in the combustion chamber and high pressure, so when we are going to spray a fine droplet of fuel, the diesel into a fine particles or droplets into the combustion chamber at that time, so it will be ignite itself automatically. It will be ignite, and the combustion process will be taken place, and the piston is going to be come from top dead center to bottom dead center. Okay, and next is exhaust stroke. So in exhaust stroke, during the combustion process, all the fuels will be burned inside of the cylinder. Okay, so when it is going to be burned inside of the combustion chamber, so due to the burn, the emissions, that means the smoke will come out from the this combustion chamber through the exhaust valve. So during this time, the exhaust valve will be in open and the inlet valve will be in closed. In exhaust valve, so we have connected the catalytic converter, muffler, silencer, and etc. So the emission, the exhaust gas will be first passed through the EGR, exhaust gas recirculation valve. So then catalytic converter, then a muffler, then silencer. Okay, so in that silencer, so we will have these type of parts. The exhaust emissions will go through this port. Similarly, the same thing also happen in diesel engines. Only the difference between the petrol and diesel engine is during the intake stroke in petrol engine, both air and fuel will be mixed together, and it will be sent to the combustion chamber. And diesel engine, only the air is drawn from the atmosphere, and it will be going enter it is entered into the combustion chamber. And uh, end of the compression stroke in petrol engine, we are going to ignite the spark, and the ignition process will be happen inside of the combustion chamber. At end of the compression stroke in diesel engines, we are going to ignite, we are going to inject the fuel into fine particles or droplets with the help of the fuel injector. So due to the high temperature inside of the combustion chamber and high pressure, the fuel will be ignited itself automatically. The combustion process will be happen in the diesel engines. So this is a cyclic process will be happening in both the petrol and the diesel engine. And the need for an injection system to supply fuel to the combustion process. To supply fuel to the combustion process, so fuel supply the petrol and diesel. And petrol, the mechanical and the carburetor system we used earlier years and earlier days. And in electronic systems, so we are using a single point, multi point, and direct fuel injection system. We are using in diesel engines also. We are having the mechanical and the injection pump, because in olden years we have used only the mechanical components or devices to inject the fuels to the engine at the right time. But nowadays we are having electronic devices, electronic methods to inject the fuels. In diesel engines also we are having different types of electronic fuel injection methods: throttle body, multi-point, direct, and common drive. So the other key objectives of the injection system is fuel efficiency, power output, emission norms, maintenance, and engine tuning. And as you know very well about the carburation is nothing but the exact proportion or ratio of air and fuel is going to be mixed together. So that is called as a, we are going to atomize the fuel. So the mixing air and fuel in a specific ratio. So that is called as a carburation. So the carburetor atomizes the fuel and mixes with air in different proportions under varying load conditions. So the factors affecting carburetions are time for mixing and the temperature of air, engine speed, carburetor design, and fuel quality. So these are all the important things so which will affect the carburetor, the efficiency. The loads, so depends upon the varying loads. So we are going to mixing the fuel at right time. And if temperature of the air is exceeds the targeted value, so definitely, so it will, that is not useful for the combustion process. The combustion process will not very much efficient when the intake temperature of the air is very much higher than as we fixed earlier. And engine speed, abnormal engine speed, and the carburetor design and fuel quality. So these are all important parameters that will affect the carburation. On loads starting idling, there is no, in during idling, no acceleration, and cruising the same speed. Accelerating, sudden velocity will be increasing. So varying load conditions also we need to send the proper ratio of the air fuel. And this is air fuel mixture ratios. So rich mixture, so we need to send the excess fuel and less amount of air. And in lean mixture and stoichiometric mixture, so we need to send the high amount of air and less amount of fuel. So you should always keep in your mind during the uh, rich mixer. So definitely we will send lot of fuel and less amount of air. Okay, and in lean mixture, so we will send a more amount of air and less amount of fuel. In between the lean mixture and rich mixer, so we will have the chemically corrected or stoichiometric ratio fuel, so that fuel is will be give a better result, as well as the lean mixer also will give better fuel efficiency. And if you want to accelerate your vehicle at more speed, or if you want to go with your vehicle at high speed, so definitely you need to use a rich mixer, so that will helpful to run your vehicle at a maximum speed. Okay, and this is a simple diagram which explains about the air fuel ratio, the amount of kg of air and the kg of fuel. Okay, and this is the power output, and this is a specific fuel consumption. And the best power, so we will get at the 12 is to 1, and stoichiometric ratio 15 is to 1, and 16 is to 1 is best economy. Okay, the quantity of air is very less in best economy. Quantity of air is very best in best economy. And the best power, so you should think the more amount of fuel. When you want more amount of power output, so definitely you should use more amount of and less amount of air. And why no stoichiometric ratio is used? The stoichiometric ratio equal to exactly all available oxygen is used to burn fuel. With the engine modification and time, the high compression ratio and larger piston bore produce high power and torque. For example, Royal Enfield, you just to see the Royal Enfield bike. The Royal Enfield bike, we will have a high compression ratio and a larger piston bore, so that will definitely produce high power and torque when we compare with other bikes. And time consumption process usually completes in 4 to 5 milliseconds at 6,000 RPM. And load and temperature. At high loads, stoichiometric ratio burns very hot, and pre-detonation might occur, causing engine damage.
Variable ignition timing advance. Modern electronic fuel
This is
injection
another simple
systems
video.
often control more than just fuel delivery. The spark events are also controlled by the ECM. Depending upon engine speed and engine load, the spark event may be required to occur much sooner or later in relation to the piston traveling toward top dead center. Variable spark advance is a tool used to always keep the engine producing maximum leverage on the connecting rod and crankshaft, thus making the most torque and efficiency possible. If we take a closer look at the process, fuel takes some time to burn inside the combustion chamber relative to engine speed. To accommodate this, the spark event needs to happen much earlier than the piston achieving top dead center. Here we can see the fuel-air charge being compressed during the compression stroke. Once the crankshaft reaches a predetermined angle, as pointed out to the ECM by the crankshaft position sensor, the ECM closes the ground to the ignition coil, completing a circuit. Up to 15,000 volts now travel at the speed of light to the spark plug and jump across the air gap to start the fire in the combustion chamber. Four-stroke engines require 2 full turns of the crankshaft or 720 degrees of rotation to complete one full cycle for an individual cylinder. If we look at the spark events during various operation modes, we can see the difference of when the spark occurs relative to engine rotation degrees. Let's look at some varying operating condition examples. When the engine is operating under moderate load and high-speed conditions, the proper spark advance will be delivered at 340 degrees, or 20 degrees before top dead center. When the engine is operating under light load and high-speed conditions, the proper spark advance will be delivered at 319 degrees, or 41 degrees before top dead center. When the engine is operating under heavy load and high-speed conditions, the proper spark advance will be delivered at 349 degrees, or 11 degrees before top dead center. Here are examples of how improper timing can affect the engine's performance. Let's say the engine is operating under moderate load and high-speed conditions, and the spark advance is delivered too early at 319 degrees or 41 degrees before top dead center. This can cause improper combustion events like detonation that affect power and performance and can even damage the engine. As a final example, say the engine is operating under moderate load and high-speed conditions, and the spark advance is delivered too late at 355 degrees or 5 degrees before top dead center. This can cause poor engine power, excessive exhaust gas temperature, and a glowing exhaust system due to the wasted energy being placed into the exhaust instead of producing useful work. Once the mixture is ignited, it rapidly burns and expands. This expansion of gases is what is used to drive the piston down, thus turning the crankshaft. This process requires a careful balance, as there are many ambient variables that affect the optimal timing. This functionality is a major improvement over a fixed timing system, and is the other half of how EFI brings refinement, performance, and fuel economy improvement over their carbureted counterparts.
Okay, guys. So now the video I think briefed about the fuel injection system of the variable engine cylinder diesel engines. So now let us discuss about the simple carburetor. So this is one of the basic thing in IC engines and all two-wheelers and four-wheelers before inventing of the fuel injectors. So we have used this carburetor system, the simple carburetor system. This is going to work on Bernoulli's principles. So these are all the various parts: choke and fuel discharge, venturi, throttle valve, and fuel metering orifice, idling adjustment, float chamber, float pivot, and fuel supply valve into atmosphere, idling air bleed, idling air restriction, and air fuel both will be mixed together because air is come from this way and fuel is going to come from this way. Both air and fuel going to mix in this area, and the mixed air fuel mixer is enter into the cylinder during the intake or suction stroke of ICH. So the air comes from the filter and this air is going to pass through venturi. Then velocity increases and pressure decreases when it passes through the venturi. And partial vacuum called carburetor depression is going to occur in this particular area. So this causes fuel to come out of the nozzle as spray, because here we are having a floating chamber and that floating chamber we will have a fuel. So when the vacuum is going to create it, and when velocity increases and pressure decreases on this particular area, so the fuel is going to be sent it through the float is going to be increased. The fuel is going to be come from this way and injected through the nozzle, and both air and fuel is going to be mixed together. This simple carburetor. So this is a complete carburetor. Here also we are having idling adjuster, and air is going to pass through this way and air fuel is going to come this way. Here we are going to using a choke for a cold start, and here we are having a fuel in and fuel filter we are using, and vent to atmosphere, and air bleed and idling air restriction, float port. So idling system, actually port system for cruising we are using here this power investment by economizer system, and accelerating pump system and choke we are using. And this is the auxiliary port and power enrichment and accelerating pump. We are having three different types of calibration, and here we are using a butterfly valve, and here also we are using a orifice, and here we are using a pump. So in this auxiliary port, it will improve the fuel economy during the cruising, and as well as valves opens to permit more airflow, and this will reduces the depression in main line and fuel consumption. In power enrichment type, the increase fuel intake to achieve more power. Addition fuel orifices opens beyond a particular throttle position. This accelerating pump duties increase fuel intake during sudden acceleration. Rapid opening of throttle moves the plunger into the cylinder, and additional fuel is going to be pumped into the venturi. And there are different types of carburetors we are having in olden years: the updraft calculators and downdraft calculators and crossdraft calculators. So updraft calculators, this will lift the fuel droplet by air friction, and for small mixing tubes we are using an updraft. So the air is going to this way, the pressurized air is going to enter into this way, and due to the velocity increases and pressure decreases, and partial vacuum is going to be created. The fuel will be come out from this floating chamber, and this will pass us through this way because of the air is going high pressure air is going to pass through this way, and the small droplet of fuel is also mixed together and it will enter into the intake cylinder during the suction stroke. And the downdraft, the fuel flows due to gravity and placed higher above intake manifold, and the crossdraft right angle turn in inlet is eliminated. Resistance to flow is reduced. And there are some drawbacks. The provides required air fuel ratio at only one throttle position, and other position fuel is either lean or rich mixture, and primarily works on air pressure difference, which is not proper always. And opening the throttle always increases engine speed, but as load is also a factor, opening the throttle may not increase the speed.
Your motorcycle is either being fed fuel through a carburetor with jets or via
And this
a
is
throttle
video
body
explain
with an
about
injector.
the simple
What
difference
happens when
between the
these two
carburetor
face
and
off?
the fuel
We'll
injectors.
find out in this video from the MC Garage. Carburetors and fuel injection both have the same job to do, which is to mix fuel and air in the right ratio for proper combustion. Carburetors are your old school analog option, and they're what all motorcycles relied on up until fuel injection began to arrive in the 1980s. Nowadays, pretty much all bikes have fuel injection, though some scooters and small displacement bikes still use carburetors to keep costs down. This thing may look complicated, but it's actually a pretty simple device. Intake vacuum, created by the piston moving down in the cylinder, draws gas up out of the float bowl and into the combustion chamber. That is a super simplified explanation of how this sucker works, but my point is that carburetors are entirely mechanical. That is both a blessing and a curse, because carbs don't require electricity or external systems to do their job, but they are affected by air temperature and elevation, and that in turn affects the way your motorcycle runs. Electronic fuel injection, on the other hand, doesn't care if it's hot out, cold out, or if you're riding at sea level or up at 10,000 feet while going over a mountain pass. This guy may look less complicated than a carburetor, but the fact is there's a lot going on with fuel injection, and there's electricity plus various sensors and circuit boards helping this guy do its job. The main difference is that rather than reacting to pressure changes like a carburetor, EFI makes its own pressure, the fuel pump, so it can inject gas into the engine anytime it wants. With all of its sophisticated components, fuel injection is a far more precise means of delivering fuel into the engine, and that means your bike's going to run better. Plus, with fuel injection, you don't have to deal with a choke lever on cold starts, you don't have to deal with a leaking petcock or float bowl or gummed up jets. The fact is, modern fuel injection is extremely reliable, and you're unlikely to have any issues with your fuel system. That being said, if you do have any problems, you're not likely going to be able to fix it on the side of the road, and replacement parts like a new fuel pump or throttle position sensor are expensive. Meanwhile, carburetor parts are relatively inexpensive, and these things are simple enough that you can work on them at home with basic tools. Unfortunately, if your bike does have carburetors, you will end up working on them. And while the work itself isn't usually that difficult, it is time-consuming and inconvenient. It's those maintenance and reliability issues that have helped make fuel injection so popular, while carburetors have become pretty rare. What's really killing carburetors, though, are environmental concerns. EFI is dynamic, and it can stick to an extremely narrow air-fuel ratio that gets you better fuel efficiency and reduced tailpipe emissions. Whereas carburetors here, with their fixed orifice jets, just aren't that adaptable or precise. And even when carbureted bikes are sitting still and not running, they're still wafting gas vapors into the air from the open vents in their float bowls and their gas tanks. With today's emission standards, that sort of stuff just isn't going to fly, so manufacturers have switched to fuel injection. So there you have it, a quick comparison of the two technologies that are feeding fuel to motorcycle engines. I hope you enjoyed it. I hope you learned something. I hope you will subscribe. Until next time, ride safe.
The advantages of the ignition system is the fuel quantity is going to be controlled at a very accurate range. So we can avoid the excess fuel sent to the cylinder during the intake or suction stroke when we uh, have the electronic fuel injection system. And the operation of the injection system is very closely matched with the requirements of the engine, because the requirement of engine requirement is going to monitored always with the help of the sensors what we have, and that is connected with the electronic control unit or module. So it will always monitor, and based on the requirements of the engine, the fuel will be delivered to the combustion chamber. And optimal setting of air fuel mixer is for different loads, varying load conditions, whether your vehicle is running or moving or cruising or accelerating or very high load or whatever it is. So it depends upon that the air fuel mixer will be sent to the cylinder, and overrun cutoff can be easily implemented in this range. Okay, this is a common input output of the injection system. The main input engine speed and the load. Based on the inputs, the fuel ratio is adjusted by the ECU. So because based on the, as I said earlier, that depends upon the vehicle moving condition, whether it is ideal or whether it is moving or whether it is very high speed or whether heavy load is induced. So depends upon the varying factors, the air fuel amount is going to be entered into the cylinder during the intake or suction stroke. Because in ECU we have connected with the air supply, and air supply flow sensor will always monitor, and ideal mixture control and ideal speed control, and other sensor is going to connected with ECU, and the fuel supply and injection is also connected with ECU. So varying speed and load conditions, the amount of fuel will be sent into the cylinder, because this everything is going to be programmed in the electronic control unit. So this is we discussed earlier, because the engine management system, the engine speed or engine load, coolant temperature, air temperature, fuel rail temperature, throttle position, EGO sensor, battery. So everything is going to be connected together with ECU, and from that ECU we have actuator. So this left side things are shown as ECU, and right sides are actuators. So engine speed. So commonly the engine speed is going to be identified with the help of the Hall effect sensor. So this will measure the engine speed from the flywheel teeth. The output frequency is approximately to engine speed. As these different types of sensors we discussed earlier. The engine load is going to be measures intake air volume by monitoring changes in manifold pressure. So this will consist of piezoresistive chip and an IC. So when the manifold pressure changes, the resistance in the chip is also going to changes. And airflow management. So we have a van type airflow, van type system and hot wire type system. And van type system, so the measuring flap rotates, rotating the spring causes a change in potentiometer, and this will both air quality quantity and the engine load is output to the ECU. In hot wire systems, the wire is heated by input current. As air flows, wire cools. Amount of current is proportional to airflow. How much amount of airflow is entered into this in hot wire system? So depends upon that airflow, the input current is going to varies. And temperature measurement, the simple thermistor, as temperature of coolant or air increases, the resistance is going to reduces. This will change in resistance is approximately to temperature. And throttle position sensor, it is used to measure the throttle position and in turn adjust airflow. As the throttle shaft is rotated, the cam attached to it also rotates, and this will vary the voltage input according to the position of the cam. The ideal and full open contact positions are also available in this throttle position sensor. And injectors. So this is consist of the electric coils and magnets. So it is look like solenoid. This is also we discussed and how it is work also we have discussed in the previous class. When the coil is going to get energized, the magnet is going to be pulled down. The forces the fuel to be sprayed through the pintle or orifice. So you can see the pictures, the orifice plate and pintle here and how it is located. And this is the fuel injection types of petrol: single point, multi-point, and direct fuel injection system. In single point fuel injection system or throttle body fuel injection system, so we have only one fuel injection system, so that is connected with the neck or throat of the fuel injectors of intake manifold. And multi-point fuel injection system for each and every cylinder, so we are having a separate fuel injectors. So that fuel injectors are connected in common rail with the high pressure is going to maintained in common rail. And next is direct injection system. Direct injection system. So this is also look like a multi-point fuel injection system. So here also we are going to inject the fuels directly or inside of the cylinders. So these are all the different types of fuel injection system. So remaining things we will discuss in the next class. If you have any questions, you can ask me.